Okay, so today we're going to be investigating the Maillard reaction. It's one of the most common chemical reactions found in various foods and cooking. It's commonly seen in the searing of steak or the browning of steak. It's also found in coffee roasting, and it also contributes to the golden brown color of cooked French fries and the crust of various breads. So basically it involves the interaction between carbohydrates and amino acids. And so today we're going to be demonstrating this using pan-fried dumplings. So first we're going to be starting with, depending how much you want to cook, a medium to small or a large skillet, doesn't really matter. We're going to preheat it at about medium heat for a little bit. So once this is nice and heated up, we're going to start putting the pan-fried dumplings in, and then we're going to add about a cup of water. We're going to cover that up, let the water boil off for anywhere from 3 to 5 minutes, depending on how much you're cooking. And then once all the water's boiled off, we're going to bring it down to medium heat, and we're going to leave that on for about 30 seconds to get a little bit more browning. So there's a couple of different ways to cook it, but this is how my family does it, so I'll be showing you that in just a second. Okay, so now we've got all the dumplings in the pan. We've put a cup of water. Now we have it on high heat, just waiting for the water to boil off. I won't be talking about how to make the pot stickers, as that's beyond the scope of this video. So basically what's happening here is there are two types of non-enzymatic browning, and that includes both caramelization and the Maillard reaction, as we're observing here today. The difference is that caramelization involves the interactions between carbohydrates and other carbohydrates, while the Maillard reaction involves interactions between amino acids and carbohydrates. Additionally, caramelization takes place at slightly higher temperatures. So in order for us to get the optimal Maillard reaction that we want, we're going to have this pan at around 140 to 165 degrees Celsius, or 280 to 330 degrees Fahrenheit. Basically what happens is, as this is heated up, the carbohydrates are going to begin to break down, and they start to interact with the amino acids. Essentially, the reactive carbonyl group of sugar is going to react with the nucleophilic amino group of the amino acid, and this is going to form a complex mixture of various molecules, and these molecules will break down and form other molecules, and some of them will be responsible for the color, the browning, and other compounds are going to be responsible for the aroma and flavor. So there's a wide variety of uncharacterized molecules that are formed from the Maillard reaction. So basically a combination of these, depending on temperature, depending on time cooked, and all these things can all contribute to a variety of different flavors and aromas. It's also noted that this process can be accelerated in an alkaline environment. This one example would be the use of lye in lye pretzels. This is because the alkaline environment is going to deprotonate the amino group, and then it makes it more nucleophilic. So a few issues that some people have with this process is that it is potentially carcinogenic. One of the known byproducts of the Maillard reaction is acrylamide, and acrylamide is being investigated, or has been investigated, as a probable carcinogen. So it's worth noting that this process, if you enjoy flavorful, tasteful food, like many other things that taste good, it might not be that great for you. So now the water has all boiled off, and we've left it on medium heat for another about 30 or so seconds. So now we're going to remove the dumplings from the pan and put them on a plate. Alrighty, so before I go ahead and grab our final product, I thought we'd go over the reaction mechanism for the Maillard reaction. Like I previously mentioned, we have two reagents brought together under heat: a sugar, in this case dextrose, and an amino acid, represented by this generic amino group. So this nucleophilic amino group is going to attack the reactive carbonyl on the sugar. This is going to result in a 1,2 addition on the aldehyde. This generates a iminium ion, and then in order to stabilize these two charges, we're eventually going to deprotonate our alpha carbon. This is going to result in a double bond between carbons 1 and 2. The lone pair found on this hydroxy is then going to push down and form a double bond. The double bond between carbons 1 and 2 is then going to go ahead and grab a proton. The hydroxy group on carbon 6 is then going to perform a 1,2 addition on carbon 2, which cyclizes our entire molecule and eventually results in the formation of our product, N-substituted glycosylamine. So this product is relatively unstable and it's pretty reactive. It's going to undergo a number of different reactions to produce the final compounds, which give the Maillard reaction its distinctive flavors. So these are going to be things like furans and thiophene, and they contribute to the meaty, burned, roasted, caramel, toasted flavors of these various foods. So a really important reaction that this product can undergo is known as an Amadori rearrangement. The open chain products are able to undergo further dehydration and deamination to produce dicarbonyls. The dicarbonyls are an extremely important intermediate because they can go on to react with something like asparagine, and this reaction, known as Strecker degradation, is going to eventually result in the possible carcinogen acrylamide. So that's what we talked about earlier. Some concerns about the Maillard reaction is that it could result in possible carcinogens such as acrylamide. So like many things in life, it's important to think about these really delicious and great things and how we can enjoy them in moderation and how we can minimize the risk, the possible health risks. So people have recommended either trying to cook for shorter periods of time or possibly at a lower temperature. But other than that, there's not much we can do to avoid the formation of stuff like acrylamide. So here is the final product. I've gone ahead and removed it from the skillet. We can see a nice browning on the bottom of each of the dumplings, and then here, just to compare, we don't see any browning on the rest of the dumpling. Just as I mentioned before, the optimal temperature for the Maillard reaction to occur is around 140 to 165 degrees Celsius. Basically what this means is, since the way we heated it, because the pan is covered, it's similar to what you would do in a simple distillation. So as the dumpling is being heated, the temperature, the vapor temperature above it begins to get closer and closer to around 100 degrees Celsius, which is the boiling point of the water. This coupled with the conduction heating from the bottom of the dumpling is enough to cook the rest of it, but it's not quite hot enough to initiate the Maillard reaction that we see at the bottom, which is closer to the source of the heat, and also where the boiling point of the oil is closer to around 300 degrees Celsius. It's important to note that if you go above this temperature range, you're going to reach pyrolysis, which is this stage right before where things begin to burn and break down. And you'll definitely know if it's too hot, because instead of having this nice savory aroma that the Maillard reaction produces, you're going to have pretty much a burnt, smoky, charred smell, and you'll definitely know. Also, just like I mentioned earlier, the Maillard reaction is really, really important in giving really unique flavors and aromas to varying foods. And again, this ranges from brown color French fries and chips to roasting coffee and even certain milk-based desserts. If you have ever had normal dumplings, you can definitely tell that there is not the same kind of aroma and taste that you get from dumplings that are pan-fried. Both are good, but the pan-fried one definitely has a different depth to it that is attributed to the products formed in the Maillard reaction.